Hello everyone. So today we have the square root of 39 plus the square root of 3 divided by the square root of 12 all raised to the power of 7 to be simplified. So if we solve together, let's seek solution. We start by saying let the square root of 39 plus the square root of 3 all over the square root of 12 be represented as x. In that case, so s is raised to the power of 7 and is the unknown. So we keep squaring x till we achieve s to the power of 7. So let's keep simplifying this. So to fractionalize this, we can have 39 as 13 times 3 and 12 as 4 times 3. So the next line becomes 39 plus square root of 3 over square root of 4 times 3, and we are fine. And this also can be written as square root of 13 times square root of 3 plus square root of 3 all over square root of 4 times square root of 3. So square root of 3 is common in the 3 terms. We can factor that out as square root of 3. This time divided by square root of 3, what is left is square root of 13 plus square root of 3 divided by square root of 3. What is left is 1. Close the bracket, all over square root of 3 times square root of 4. So square root of 3 can cancel out. What we are left with is square root of 13 plus 1 over square root of 4, that is 2. Recall that this is what we have simplified and is equal to x. So we can say x is equal to this. Let's call it equation A. If we multiply both sides of equation 8 by 2, we have 2x equal to square root of 13 plus 1. And if we solve this very one, we're going to have 2x minus 1 equal to square root of 13. So that 2x minus 1 will be raised to power 2 equals to square root of 13 also will be raised to power 2. Here, the square root and square will cancel out. What will be left here will be 13. And on this other side, we have 2x minus 1 to the power of 2, and we are fine. But from algebra, we have a minus b to the power of 2, and it's represented as a to the power of 2 plus b to the power of 2 minus 2ab. This is in the form of this, where a is equals to 2x and b is equals to 1. So if we agree on this, our equation therefore becomes 2x to the power of 2 from here plus 1 to the power of 2 minus 2 times 2x times 1, and this is equal to 13, and we're fine. So if we solve this on 2 to the power of 2, that is 4, and x to the power of 2, that's x to the power of 2, plus 1 to the power of 2 is 1, minus 2 times 2, that is 4x, is equals to 13. If we make 4x to the power of 2 the subject of formula, it becomes 4x to the power of 2 equals to, here, 4x minus 1 plus 13. So this is the same thing as x 4x to the power of 2 equals to 4x plus 12. Here is 4x to the power of 2 equals to, what is common is 4. If we bring out 4 here, we're left with x. And if we divide 12 by 4, this is 3. So here, 4 can cancel out, and it will be left with x to the power of 2 equals to x plus 3. If we call this equation star, the value of x to the power of 2. So we'll continue to square both sides until we achieve x to the power of 7, so that x to the power of 2 also to the power of 2 is equal to plus 3 also to the power of 2. And on the left hand side, we have x to the power of 4 is equal to x to the power of 2 plus 3 to the power of 2 plus 2 times x times 3. And if we simplify this further, we have x to the power of 4 equals to x to the power of 2 plus 9 and plus 6x. We have x to the power of 2 and x to the power of 2, which is given as s plus 3. So in the place of s to the power of 2, we're going to write s plus 3. That is, s to the power of 4 is equal to x plus 3 plus 9 and plus 6x. So that x to the power of 4 can therefore be equal to s plus 6s, that is 7s, plus 3 plus 9, and that is 12. Again, we're going to square both sides. X to the power of 4 will be raised to the power 2 equals to 7x plus 12 also will be raised to the power 2. Here, x to the power of 8 is equal to 7x to the power of 2 plus 12 to the power of 2 plus 2 times 12 times 7x. And if we simplify this, we have x to the power of 8 equals to 7 to the power of 2, that is 49. And x to the power of 2 is x to the power of 2. Plus 12 to the power of 2 is 144. Plus 2 times 12, that is 24, times 7s, that is 168x. 168x. Again, we're going to replace the value of s as s plus 3, so that x to the power of 2 will be equals to 49 into x plus 3 plus 144 plus 168x. X to the power of 8 is equals to 49 times x, that is 49x, plus 49 times 3, 147, plus 144, plus 168x. X to the power of 8 is equals to 49x plus 168x, that is 217x. 217x plus 147 plus 144, that is 291. 291. So here, we're going to divide both sides by x so that we can achieve s to the power of 7. That is, x to the power of 2 over x is equals to 217x over x plus 291 all over x. X to the power of 8 times x to the power of minus 1 is equals to 217. S will cancel x plus 291 times 1 over x, and we're fine. On this left hand side, 8 minus 1, that is s to the power of 7, is equals to 217 plus 291 times. Previously from equation A, we had s to be equal to square root of 13 plus 1 all over 2. So if we take the reciprocal of x, the equation becomes 2 all over square root of 13, 1. So we're going to rationalize this by multiplying the numerator and the denominator with a conjugate. That is, x to the power of 7 will therefore be equals to 217 plus 291 times 2 into square root of 13 minus 1 all over square root of 13 minus 1 times square root of 13 plus 1. And this is in the form of a minus b times a plus b. And this is represented as a minus b to the power of 2, where a is square root of 13 and b is 1. So that the next line becomes x to the power of 7 equals to 217 plus 291 times 2 into square root of 13 minus 1 all over square root of 13 squared minus 1 squared. So that x to the power of 7 will be equals to 217 plus 291 times 2 square root of 13 minus 1 all over square root and square can cancel, so that 13 minus 1, that will be 12. But 291 can be split into 3 times 97. So the next line becomes x to the power of 7 equals to 217 times 3 times 97 times 2 into square root of 13 minus 1 all over 12. But this is plus. So here we have x to the power of 7 equals to 217 plus 3 times 2, that will be 6, times 97 into square root of 13 minus 1 all over 12. But 6 can cancel 6 to be 1. 6 into 12, that will be 2. So in the next line, we have x to the power of 7 equals to 217 plus 97 into 13 minus 1. Remember the bracket, all over 2. So if we open up this bracket, we have x to the power of 7 equals to 217 plus 97 square root of 13 minus 97 all over 2 and all over 2 in separate fractions. So that x to the power of 7 will be equal to here 217 minus 92 over 2 plus 97 square root of 13 again over 2. Is x to the power of 7 minus 217 minus 97 over 2. This is 7 plus 97 square root of 13 all over 2. So we're going to take the LCM, so that x to the power of 7 will be equal to 2. 2 times 217, that is 434, minus 1 times 97, that is 97, plus 97 square root of 13 over 2. X to the power of 7, because if we do this very one, we have 337 over 2 plus 97 square root of 13 all over 2. So that square root of 39 plus square root of 3 over square root of 12 all to the power of 7, which is represented as x to the power of 7, is simplified as 337 over 2 plus 97 square root of 13 all over 2. And this is our answer. Look forward to see you in our next video. Thank you for staying tuned. Bye bye.